Now we're going to look at one use of the dot product, which is determining if vectors are orthogonal or parallel. So let's get to it. So first, we need to understand vocabulary, because it always comes down to the words. Use your words. Speak. That's about it. But dot product and orthogonal vectors. So what's another word for orthogonal? Well, there are actually two other words that we use in math for orthogonal. Both we have seen this year already multiple times. One is perpendicular, the other is normal. So when we talk about something, a line being normal to a curve, remember I always said that that's perpendicular. It doesn't just mean that the line is, kind of average height and average build. What is normal anyway, right? I mean, your normal is probably different than my normal. My normal might be not normal. So two non-zero vectors v and w are orthogonal if and only if v dot w equals 0. That's going to make sense in a minute if it doesn't already make sense to you. Because 0 dot v is also 0, that means that the 0 vector is orthogonal to every vector. Okay, so let's make sure we understand. So why does a dot product of 0 lead to orthogonal vectors? And then let's also talk about parallel, right? Because that was part of the title of this video. So, well, let's think about how do we determine if something's perpendicular? Well, it has to do with the angle, right? So I know if two vectors are 90 degrees apart, then they would be perpendicular. You also know this relationship between vectors is that cosine of theta, where theta is the angle between them, equals the dot product over the product of the magnitudes. But if the numerator is 0, so think about this, if v dot w equals 0, then 0 over magnitude v magnitude w also has to equal 0, right? So this is saying then that the cosine of theta equals 0. Well, where does cosine equal 0? Glad you asked. Glad the unit circle is still with us. So cosine is going to equal 0 at 90 degrees or 270 degrees, both of which are perpendicular angles. What about parallel, you ask? Great question. Glad you asked. So if they're parallel, then what has to be true about cosine? So think about, let me rephrase the question. What angle or angles will result in parallel lines? So if two vectors are 0 degrees apart, they would be parallel. If they are 180 degrees apart, they would be parallel. So what cosine values will create 0 and 180? 1 or -1. What conclusion can we draw then? Therefore, that's a math symbol for therefore. If you didn't know that already, the absolute value of v dot w has to equal the magnitude of v times the magnitude of w. Oops, forgot that. And that's going back up to this equation here. So basically that's just saying that if the numerator is the same as the denominator, then you're going to get 1 or -1 if one of them is negative, which will then lead to parallel vectors. This should all make sense, hopefully. Keep in mind, so in general, and this is just me going off on a tangent right now, notice that a lot of what we've done now with vectors is we just break them down into trig components, or we break them down into components from trig. And we should hopefully have a pretty good understanding of trig. We are creating these right triangles using vectors and finding the horizontal and the vertical components. and we know that those are 90 degrees apart. We have ways that we can figure that out. Now we understand how the dot product can show us that as well. So again, this all goes back to trig. So are the vectors 3i minus 2j and v equals 3i minus 2j and w equals 3i plus 2j, are they orthogonal? Pause the video, decide, unpause when you're ready to check. So I said no, they are not orthogonal. Why is that though? So all I had to do was find the dot product. So the dot product is 3 times 3 plus negative 2 times 2, which is positive 5. That's not 0. 5 does not equal 0. I might not know a lot, but I know that. That's a fact. Next one. Are the vectors 2i minus 2j and 3i minus 3j parallel? Pause the video. Unpause when you are ready to check. So here we end up with a resounding yes. How do we come up with that? Well, there's actually multiple ways we can do this. So we can also kind of think about it too, but let's go through the math. So first I found the dot product. So v dot w is 2 times 3 plus negative 2 times negative 3, which is 12. Then I looked at what is the product of the magnitudes. So root 2 squared plus negative 2 squared times root 3 squared times negative 3 squared ends up being root 144, which is also 12. I know the cosine of theta is the dot product over the product of the magnitudes, so that's 12 over 12, which is 1. So if cosine of theta equals 1, then the angle between them is 0, so yes, they are parallel. Now that should also make sense, because think about what these vectors look like. 2i minus 2j is saying that I'm going 2 to the right and 2 down. 3i minus 3j is saying that I'm going 3 to the right and 3 down. Now, I know you might argue and say, well, doesn't that mean that they're actually the same vector, just one has a larger magnitude? And the answer is, well, sort of. Remember that we're saying that they're parallel because when we talk about vectors, they don't have a fixed location in space. So yes, we can move them, or if we graph them starting at the origin, then they will be on top of each other just with a different length or magnitude. However, we don't have to graph them from the origin. There's nothing in definitions of vectors that say we do. So that's why we say just more generically, they are parallel. All right. So we want to remember how the dot product relates to the angle between two vectors, and it will allow us to determine if they are orthogonal, parallel, or neither.